We call them rings. The word sounds gentle, decorative, something you would find on a finger, not wrapped around the planet a billion kilometers away. But what if we have been thinking about Saturn's rings all wrong? What if, instead of jewelry, they are something closer to a weapon, a storm, a debris field spinning at extraordinary speed, made of billions of individual fragments of ice and rock, each one capable of inflicting catastrophic damage on anything that dares to pass through? Now imagine something far larger than any spacecraft entering that storm. Imagine an entire planet. Imagine Earth, our home, with its oceans and continents and 8 billion people going about their lives, somehow finding itself inside Saturn's rings. What would actually happen? Would the rings simply pass around us, harmless dust in an empty sky? Or would something far more violent unfold? Something that would end human civilization in a matter of minutes, hours, or days? This is not just an idle thought experiment. To answer it properly, you need to understand exactly what Saturn's rings are made of, how fast they move, how dense they really are, and what happens when objects of very different sizes interact with debris fields at orbital velocities. And when you work through the physics step by step, when you actually follow the numbers instead of the myth, the answer is far stranger and far more revealing than anything you might expect. Because the rings of Saturn are not what they look like in photographs. They are not a solid, gentle halo. They are a battlefield. And Earth, stepping into that battlefield, would discover something about itself that we rarely have cause to think about. To understand what would happen to Earth, we first need to abandon the picture in our heads. Saturn's rings are not a solid disk. They are not smooth. They are not continuous sheets of material spinning gracefully around the planet like something from a science fiction film. They are made of countless individual particles, trillions upon trillions of them, ranging in size from microscopic grains of dust to chunks of ice and rock the size of a house, and in rare cases, possibly larger. Most of the material is water ice, remarkably pure, some of the brightest, cleanest ice in the solar system reflecting sunlight so efficiently that the rings can be seen from Earth through a basic telescope. The ring system stretches across an enormous area. From the inner edge to the outer edge of the main ring system, the span reaches roughly 280,000 kilometers. That is nearly 3/4 of the distance between Earth and our moon. And yet, despite that enormous span, the rings are astonishingly thin. In most places, the vertical thickness of the rings is less than 1 kilometer, in some sections as little as 10 meters. A structure 280,000 kilometers wide and in places only 10 meters tall. If you scaled Saturn's rings down to the thickness of a sheet of paper, the diameter of that ring system would stretch for kilometers. This combination, vast width, razor thinness, is part of what makes the rings so visually striking, but it also tells us something important about the density of material within them. Despite containing trillions of particles, the rings are mostly empty space. If you were flying a spacecraft directly toward the rings from a distance, in many regions you might pass through without colliding with anything at all purely by chance, depending on exactly where you crossed. But not everywhere. In the densest regions, particularly the B ring, the brightest and most opaque section of Saturn's ring system, particle density increases dramatically. Sunlight struggles to pass through. Collisions between particles are frequent and ongoing, constantly grinding larger objects into smaller fragments, constantly redistributing material throughout the ring plane. And every single particle in that ring system, whether a speck of dust or a boulder the size of a building, is moving fast. Particles in Saturn's rings orbit the planet at approximately 70,000 kilometers per hour, depending on their exact distance from Saturn. Material closer to the planet moves faster. Material farther out moves slightly slower, following the same orbital mechanics that govern every object circling a massive body. 70,000 kilometers per hour is roughly 20 kilometers every second. At that velocity, even a small piece of ice carries enormous destructive energy. It is not the mass of these particles that makes them dangerous, it is the speed. Kinetic energy increases with the square of velocity. Double the speed and the destructive energy quadruples. The particles in Saturn's rings are moving at speeds that would make even tiny fragments lethal to any spacecraft, structure, or living thing they struck. Now place Earth into that environment. A planet 12,742 kilometers in diameter, with an atmosphere, oceans, and the population of 8 billion people, suddenly surrounded by this fast-moving field of icy debris. What happens next depends entirely on where exactly Earth finds itself within the rings. And the answer is more nuanced, and in some ways more terrifying than a simple yes or no. Let us be precise about scale. Earth's diameter is roughly 12,742 kilometers. Saturn's entire ring system spans about 280,000 kilometers. This means that even a planet the size of Earth, placed somewhere within the ring system, would occupy only a small fraction of that vast structure. But small fraction does not mean safe, because Earth would not simply sit motionlessly inside the rings. It would be moving through them, sweeping up material as it traveled along whatever orbital path it found itself on. And the rings themselves are composed of particles traveling at their own independent velocities, in their own orbits around Saturn. The relative velocity between Earth and the surrounding ring particles would be the critical factor. If Earth entered the ring plane and matched the orbital velocity of the surrounding particles closely, the actual relative speed of impacts might be lower than the raw 70,000 kilometers per hour figure suggests. But achieving that kind of orbital matching for an object the mass of Earth suddenly inserted into Saturn's gravitational environment is astronomically unlikely. Far more probable is a violent, continuous bombardment. Picture it. Earth, moving through a debris field made of ice particles ranging from dust grains to boulders the size of buildings, all traveling at velocities measured in tens of kilometers per second relative to our planet. The atmosphere would be the first line of defense, and also the first thing torn apart. Earth's atmosphere already protects us from millions of small meteoroids every single day. Most burn up harmlessly, friction with the air vaporizing them long before they reach the surface. This is happening constantly, invisibly, all around the planet. But Saturn's rings would deliver far more material, far more densely, far faster than anything Earth's atmosphere has ever been asked to handle. In the denser regions of the rings, the sheer number of particles striking the atmosphere every second would generate immense friction and heat. The upper atmosphere would begin to glow, then heat dramatically, potentially stripping away atmospheric layers through ablation, material being torn off the top of the atmosphere by the sheer force of repeated high-speed impacts. Larger fragments, the house-size and building-sized chunks of ice scattered throughout the rings, would not burn up in the atmosphere. They would punch through it. Each impact would carry energy comparable to a significant asteroid strike. Multiply that by the number of large fragments Earth would encounter while crossing through a dense ring section, and you arrive at a bombardment scenario far beyond anything in the geological record of our planet, far beyond the impact that ended the age of dinosaurs. This would not be a single catastrophic event. It would be continuous, ongoing, a planet being sandblasted by ice and rock for as long as it remained within the ring plane. Surface devastation would be total in any region directly exposed to the densest parts of the rings. Firestorms triggered by atmospheric heating, tsunamis from oceanic impacts, dust and vaporized ice thrown into the atmosphere, blocking sunlight, plunging the planet into a sudden artificial winter on top of everything else. And there's another factor we have not yet addressed: gravity. Earth is not a passive object, simply absorbing impacts. Earth has its own gravitational field, strong enough to influence anything nearby. As Earth moved through Saturn's rings, its gravity would begin to pull on the surrounding ring particles. It would not just be hit by the rings, it would start eating them. Gravity does not care about size differences the way our intuition does. Earth's mass is approximately 5.97 times 10 to the 24th power kilograms.
Compared to the mass of Saturn's entire ring system, estimated at somewhere between 1/10 and 1/2 of the mass of Saturn's moon Mimas, Earth absolutely dwarfs the rings. Mimas itself has a mass of roughly 3.75 times 10 to the 19th power kilograms. Earth outweighs the entire ring system by a factor of well over 1,000,000. This means that if Earth were placed within Saturn's rings, our planet's gravity would dominate the local environment around it. Ring particles within Earth's gravitational influence would not simply continue along their original orbital paths. They would be pulled toward Earth, captured, redirected, drawn inward by a gravitational field far stronger than anything they had experienced while orbiting Saturn at that distance. In effect, Earth would begin clearing a path through the rings, sweeping up material in its vicinity the way a snowplow clears a road, except instead of pushing material aside, gravity would be pulling material directly toward the planet's surface and atmosphere. This process has an actual precedent in our solar system. Several of Saturn's moons, including Pan and Daphnis, are known to clear gaps in the rings through exactly this gravitational mechanism, though on a vastly smaller scale given their modest size. Earth, with its much greater mass, would clear a far larger gap, possibly a gap stretching for tens of thousands of kilometers along Earth's orbital path through the ring plane. But clearing that gap would not be a clean or gentle process. It would mean funneling enormous quantities of ice and rock directly into Earth's atmosphere and onto its surface. Every particle Earth's gravity captured would eventually fall inward, accelerating as it approached, striking the planet with whatever velocity gravity and orbital mechanics combined to give it. The total mass of material Earth might sweep up, depending on exactly where within the rings it found itself and how long it remained there, could be staggering. If Earth lingered within the densest part of the B ring for even a relatively short period, astronomically speaking, weeks or months, it could potentially accumulate a significant fraction of the ring system's total mass. Some of this material would add to Earth's water supply. Ice, after all, is mostly water. In a strange and almost beautiful irony, an apocalyptic bombardment from Saturn's rings would also be delivering trillions of tons of fresh water ice to a devastated planet. Cold comfort, in the most literal sense, for a civilization otherwise being destroyed. But this raises an important point about scale and perspective. As violent and devastating as this scenario would be for life on Earth, it would barely register as a blip in the life of Saturn's ring system as a whole. The rings extend across hundreds of thousands of kilometers. Earth, even while devastating a substantial swath of material in its immediate vicinity, would only be interacting with a relatively narrow slice of a vastly larger structure. From the perspective of the rings themselves, Earth would be a localized disturbance. A wound, certainly, but not an extinction event for the system as a whole. From the perspective of life on Earth, the calculation would be entirely different.
This scenario will never happen. Earth orbits the Sun at a stable, predictable distance. Saturn orbits the Sun at a completely different distance, separated from us by well over 1 billion kilometers at the closest approach between our two orbits. The gravitational mechanics that keep our solar system stable have operated this way for over 4 billion years, and they show no sign of changing in any time frame that matters to us. This was always a thought experiment, but like every good thought experiment, it was never really about the scenario itself. It was about what the scenario reveals, and what it reveals is this. The rings of Saturn, despite their delicate jewelry-like appearance from a distance, are an environment of extraordinary violence, a debris field moving at velocities that would make even small fragments catastrophically destructive, a structure that exists in a permanent, ongoing state of collision and redistribution, grinding larger objects into smaller ones across billions of years.
Beauty in the universe is rarely gentle. The same forces that make Saturn's rings so visually spectacular, the precise orbital mechanics, the countless particles catching sunlight at just the right angle, are the same forces that would make them instantly lethal to anything fragile enough to need protection. And Earth, for all its apparent solidity, all its mountains and oceans and ancient bedrock, is fragile. We forget this constantly. We live our lives on a surface that feels permanent, stable, unshakable. We build cities that we expect to stand for centuries. We plan decades ahead, sometimes generations ahead, operating on the unconscious assumption that the ground beneath us, the atmosphere above us, the gentle rhythm of day and night and season and tide will simply continue. And for the most part, they will. Earth has weathered asteroid impacts, supervolcanic eruptions, ice ages, and mass extinctions across its 4.5 billion year history, and life has always found a way to continue, even when it had to start nearly from scratch. But the thought experiment of Earth meeting Saturn's rings is a reminder of just how much protection we quietly benefit from every single day. The vast, empty distances between planets, the stable, well-separated orbits that keep us away from debris fields, asteroid belts, and the violent gravitational dance of our outer solar system. We are not protected because the universe is gentle. We are protected because we happen to be in a quiet corner of it. A corner where the rings are 100 million kilometers away rather than wrapped around our own planet. A corner where the asteroid belt stays mostly in its lane. A corner where, for now, the cosmic shooting gallery mostly misses us. That is not destiny. It is not guaranteed forever. It is simply for this moment in cosmic history our extraordinary good fortune. So perhaps the final lesson of this impossible scenario is not really about Saturn at all. It is about gratitude for the silence between us and danger, for the vast, undramatic emptiness of space that keeps Earth exactly where it needs to be, far from the rings, far from the debris, far from the violence that defines so much of the rest of our solar system. Saturn gets to wear its rings like a crown. Earth gets something better. It gets to be left alone. And in a universe this vast, this violent, and this indifferent, being left alone, quietly orbiting in the calm, is the rarest gift there is.